So this is a recording that caters to the concept of significant figures. If you should read the resources provided for this module under rounding off, you would have seen the authors in your textbook, which is used to create the lecture notes and the content for this module, that they alluded to keeping significant figures. So if you should multiply a number with long places of decimal, like 5 places of decimal, and you're multiplying it by something with 1 place of decimal, then the 1 place of decimal number would have the least significant figures. It simply means your answer should be reported to that. So sometimes students do calculation and you get the answer for a dosing, and the dosing is written as 3.5454 milligrams. No, you should be confident in your rounding off, because in the previous recording we spoke to the concept of error, and error is fine within a certain perimeter fencing. That perimeter fencing, 5%. Do you need to maximize the 5%? No, but you're going to operate with that in mind. Significant figures. The number of significant figures in a result is simply the number of figures that are known with degree of reliability. It means that you're confident that this instrument will measure or weigh this quantity that you're stating. Significant figures are important whenever you're weighing or measuring, because you want a level of accuracy with the device that you're using. Okay, patient dosing too will, when you get body weight and meter square and milligram per kilogram, sometimes you may need to round off, right? So for example, 13.2 is said to have 3 significant figures. The number 13.20 has 4 significant figures, because the mere fact that the authors have added a 0 after the 2 means that that's the level of accuracy and certainty or reliability that the authors want, or else they would have not included that 0. So sometimes you need to ask yourself, do I really need that 0, and why? So let's look at the rules very quickly for significant figures. All non-zero digits are significant. First rule, all non-zero digits are significant. So for example, 1.2 gram has 2 significant figures. 1.25 has 3 significant figures. 1.234 has 4 significant figures. Let's look at the next one. Zeros between non-zero digits. That's the operative word, between. Let me highlight. So zeros that falls between non-zero, for example, 3.07, there is a 0 between 2 non-zero digits. So therefore, the numbers are significant. So this one has 3 significant figures. The zeros between the 1 and the 2 here to read 1,002 kilogram has 4 significant figures, because the 0 falls between 2 non-zero digits. 102.56 kilogram has 5 significant figures, again because the 0 falls between 2 non-digits, which is the 1 and the 2 non-zero digits. Now, these are, if you look at the footnote of the resources I've shared for this module, these are some sites you can go, and you actually have calculators that you just plug it in and it tells you the significant figure for a number, right? There's so much resources online. Let's look at this one. Zeros to the left, right, of the non-zero digits are not significant. To the left, you know. So let's look. The 0.5, the 0 is to the left of the decimal. So you have, they're not significant once it's to the left of the first non-zero digit. So let's read it again. The 0 to the left of the very first non-zero digit. So this is a non-zero digit. So the 0 to the left of it would not be significant. So this has one significant figure. In this case, there are 2 zeros to the left of the non-digit number. So therefore, you have one significant figure still. That's a tongue twister there. There are 3 zeros before this temperature reading, and the first non-zero number is 1. So it still only have one significant figure. Okay, this one has 2 zeros before the first non-zero number, but it has 2 non-zero numbers, which is 23 or 0.023. And so you have 2 significant figures. Here, the 0 appears between 2 non-digit numbers, so it would count, but these are before, so those 2 zeros would not count. This 0 would not count, and this 0 would not count. So therefore, this has 3 significant figures. This one has 4 significant figures because the 0 is to the right of the non-digit number, so we would count it. But these 2 zeros to the front of the first non-digit number, we would not count. Let me put that in a different color here for comparison, right? We would not count those. Over to this one, zeros to the right, just like this one. This 0 is to the right. Over here, these zeros are to the right of the first non-digit number. So that would be significant. So this has 3 significant figures. All right, let me see what else is there. And so that should cover. I just want to make sure that we're finished. There we go. So it's significant figures is really not, I'm not going to say it's easy. It can be a mind-boggling thing sometimes, okay? But it says when a number ends in zeros that are not to the right of the decimal, the zeros are not necessarily significant. Okay, let's read that slowly. When a number ends in zeros, so the number ends, oops, let me undo. I think we're going to a new document. I'm not sure what I clicked. Sorry about that. I think I pressed Control N or N. Okay, let me go again. When a number ends in zeros, Control B, underline. I pressed the wrong thing a while ago. I think I pressed Control N, which is a new page. When the number ends in zero, so let's look, 190 mile, it ends in a 0. 50,600 calories, it ends with zeros. They are saying the zeros are not necessarily significant. So this one may be 2 or 3 significant figures. This one may be 3, 4, or 5 significant figures. So you know what, students? Don't confuse the brain about that one. The only thing I will tell you is this is going to bring us into the next topic. So the potential ambiguity, isn't this awesome? The ambiguity that this may creates is going to lead us into our next topic. This is why standard form or scientific notation was created to avoid. So whenever this rule applies that a big number ends with 0, to eliminate the ambiguity, you convert a number to a standard form. And that is where our next topic in pharmaceutical calculation, fundamental concepts, will begin. So 50,600, I think it should be 600 calories because it's 600 here. I had an extra 0. Can be written as 5.06 times 10 to the 4. Let's see why we get 10 to the 4. Let's go. Let's draw. Let me see if my thing will help me to draw. Because we're moving 1, 2, 3, 4. Do you see that? The decimal place will come right here between the 5 and the 0, right? So the answer is 5.06. So that will times 10 to the 4, because we have moved 4 points over to relocate and create a decimal point. Standard form or scientific notation help big numbers, whether positive or negative numbers, to be reader friendly. If you were moving the decimal to the, is it the right? The number would be negative. If you're moving it as we did to the left, the power that the number is raised to for 10 is a positive number. Okay? Now, what if you should add a 0 after the 6, as we have done here? Then the rules for significant figures chips back in, where the 0 after the non-digit number is significant. So as long as you add zeros to the left of the number, right, after the non-digit number, those would be significant. So I hope this has brought us to the end. Let me see what this summary document says. The United States Pharmacopoeia states that in performing pharmaceutical calculation, all figures are to be utilized until the calculations are completed, and then only the significant figures retained in the final answer. That's what Pharmaceutical, the United States Pharmacopoeia, you may see the abbreviation USP used a lot. That's what it means. When weighing or measuring, keep in mind that the calibration of the device, so this is about accuracy in weighing and measuring, or the sensitivity of the balance is important. Sometimes we are asked to record a value correct to, and it tells us the number of decimal places that we should report or answer to. This must not be confused to significant figures. And so this topic is just raising the awareness that the number of decimal places is very different from saying that a number is significant. All right, so with that said, that has taken us to very short recording. This one is in 12 minutes. Significant figures. And so I'm going to do the last recording. I am saying hip hip hooray. I'm going to do the last recording for exponential notation, and that would sum up all the subtopics for Unit 1, which is coming on your screening assessment. And why are we doing the screening assessment? These are all foundation mathematical principles that you should have grasped confidently with 100% accuracy before you really can move on to the more advanced topics, which are really a part of the syllabus for pharmaceutical calculation. Thank you for watching this video.